Hi, I'm Nick. This is Top 5 Unity Tech Tips Union now. Feel free to follow along the starter project code that is linked on GitHub. It should be publicly available. Anyone that wants to follow along can use the link here or in the Discord post in the workshops channel. Today we're going to cover 5 topics. I'm trying to hide the Zoom screen. The 5 topics are going to range from prefab variants, which are pretty much making greater use of the prefabs that are already a core part of Unity. We're going to talk about animation overrides, which is an important tool for replicating animation logic. We're going to talk about scriptable objects and how they differ from model behaviors. We're going to talk about code organization, which is really several smaller tips in a trench coat. Important devices for modularizing your code and keeping things well organized. And last, we will end the discussion with custom editors, which are a very powerful tool built into Unity and allow you to do a lot more with very little effort. But before we do any of that, I'm going to introduce you to a friend of mine. This is Doug. Doug is going to be the focus of us going through these 5 points, as we essentially are going to open a project where we're going to make a friend for Doug. We're going to make Doug's friend look a little different. We're going to create a tool to easily store data for Doug and their friends. We're going to use our code organization to just help make things look a little nicer for Doug in the back end. And then we're going to add a custom character switcher as part of the inspector. I'll take pauses at each of these points, so if there are any questions that somebody can just raise their hand at that point. We're actually going to dive right into the project. Hide the loading controls because there was such a while. All right, so this is the starter scene, just to get us orientated for a little bit. The entirety of the starter scene really is the simplest code, and it's mostly just some beautiful art assets to give Doug a nice little enrichment area. So what we have here is a Doug who can walk left and right. He's got a little walk, little idling animation. There's a nice little background and some art assets for the ground. But that's really all Doug can do, and Doug gets lonely. Stop playing now. So as we can see right now, Doug is currently existing as a prefab. I'm going to keep calling him Doug, even though it's an X, because I do not know how to pronounce that. Doug gets a little lonely, so it's just Doug. That's all there is in this project, really. So what we're going to do is we're going to work with our first part of the 5 tips. Tip number 1, which is how to make use of prefab variants. Prefab variants are pretty much saying, hey, if you already know prefabs. Prefabs are blueprints for you to follow in Unity to essentially be able to pull from things that you want to put in multiple scenes in multiple places. This is a great and powerful tool, but it can be greatly extended with variants. For example, Doug has a lot of unique behaviors. He has an animator, he has a rigid body for collision, he's got a collider for collision, and he's got a nested structure internal to him regarding how the graphics are organized. That's all very good and well, but Doug needs also a player controller script, which lets me move left and right. Now, 99% of that is also going to be needed if I want to make a new character who isn't the player. In fact, I'll need everything here except for the player controller script. So what I could do is I could copy and paste Doug, which we want to do. We copy and paste, and I have Doug 2, Doug 1. But that's not a great practice, because now if I wanted to change one of these things, I have to change both of them. And if I have 5 or 6 different versions of Doug, or different versions of this basic prefab, it gets to be a real pain. So what we're actually going to do is we're going to delete Doug 1. And what we're going to instead do is make a variant. This is done by dragging any prefab who already exists back into the project window to make a new prefab, and this will pop up. It says, hey, do you want to create a new original prefab, much like what we just did with copying and pasting, or we want to make a prefab variant? We're going to pick this second option. This prefab variant is the same thing as we just saw, as you can see, except it has a little difference. This prefab variant has the word variant at the end, and it references another prefab, Doug. Now, this original prefab doesn't have another reference because it is the base prefab. This is the thing that we originally started with. Doug variant is based on that. So if I make a change to Doug, let's say if I make Doug, let's change his position to be 0. Just a quick little reset. That's the wrong place to put the 0. Let's scale Doug down back to 1. Doug variant will be scaled down to 1. You'll notice that position and rotation aren't adjusted. That's because the bold text there indicates that those values are actually not really recorded by prefabs. If you change them on any prefab, it won't really matter. But scale is, which is why it's not bold. Similarly, move speed can be changed on the base. It'll reflect here. Yep, same values, even though I didn't change them both places. But the key difference is if I change move speed on the variant, on the thing based off of the original value, or the original prefab, you're gonna notice the blue flag that's usually there whenever we make changes to a prefab in the scene. And in this case, the base prefab does not have those changes. The whole point of using variants is so that we can make something that has a blueprint that refers to another blueprint. We can make general changes on that basic original prefab that can be propagated to all the other variants, or we can make specific changes that we want on only one variant by changing it. It's a very powerful tool that allows us to make changes rapidly across our project. In this case, we're going to change one of these prefabs into a friend for Doug, one who doesn't have any player controls, and we're going to keep the other one as the player control version. As such, I'm actually going to rename the variant to player and the original Doug character. The original Doug, the character we'll call him from now on, doesn't need a player controller script. So we're actually going to remove that. And what that will do is, of course, remove it from our player script. But we're going to do that because we're going to add that player controller script back to the player, because it's very important that we realize, hey, I am adding something that I don't have in the base, so I should do it on the level that it actually is relevant. So in this case, I'm adding a very simple player controller script. We don't really care all that much about the code. It is really just left and right walking. I'll open it up and show you just to make sure you're not too suspicious of me. But while it's opening the background, you'll notice that we have a player controller script on player and no such script on character. What this allows us to do, and I'll open this up now. Oh, still loading. What this allows us to do is drag a character into the scene who isn't going to move. You'll notice they're a little small now, so let's actually scale them back up. They should all be scaled now, and they are. There's a character in the scene, there's Doug in the scene. We should make that the player, even though it's just the same name. So now, when I originally had was behavior where if I press left or right, all the characters would move. Now, when I press left and right, only the player will move. And Doug's got a little friend. Isn't that nice? So that's the long and short of prefabs and prefab variants. You can see the player controller script is not all that deep. It really is just left and right. We move it. Does anyone have questions about prefab variants before we move on? Yes.
Do you show how you did that blue flag down?
Yeah. So the blue flag happens whenever a change is made on the prefab variant. It's just like the change that you see in the scene. So for example, if I found a prefab like this and I wanted to change one of its values that aren't in bold, let's say remove its controller for animation, the blue automatically shows up. That is just to indicate that a change has been made that is different from the blueprint that you based off of. When you right-click that blue flag, or the text associated with it, you were able to apply that prefab change, which means the blueprint will update to be this value of none, or I can revert it going back to the original value in the blueprint. This same thing happens with the variants. So if I go into player and I change Doug to none, removing its animated controller, the same thing happens where the original prefab obviously doesn't have the change, but the blue flag indicates that a change has been made based off of its blueprint. This can be reverted, and then we can go back to where we were. No problem. All right, so that's prefab variants, but the second that we next want to talk about is, hey, let's get Doug's friend to look a little different than him. I think Doug looks a little bit alike. And the reason that this is a cool tech tip is because you can really get bogged down a lot of art implementation, especially if you're not careful. I'm going to show you the options we have for Doug's friends. Oh, by the way, all these art assets are freely available online. I have attributions here. There is the backgrounds from Genshin Impacts, someone made some fan art, and the Dino characters are also available on itch. So if we open up Dino folder, and we can see Doug, obviously there is a little bit of art assets and playing around with them to get the right settings here. You can see I've changed the pixels per unit to include the 24 that the characters are actually sized at. I've changed our filter mode to point, which you should always use for pixel art. And I've made sure to cut it from multiple sprites. I haven't made any of these changes to the other art assets, which means if I wanted to actually import everything in, I'd have to by hand go through, and replicate these. I can do it all at once by selecting multiple, but I still would need to look at Doug and look at the other ones, and look at Doug, look at the other ones, and that's a real pain in the ass. So what we're going to do is we use what's a sprite import preset. Actually, to select Doug first. So Doug has all the settings I want for the other dynos. They're the exact same sprite sheets. I just want to carry those settings over. I'll create a sprite import preset. I'm going to call it Dino because this refers to all the dynos. And I'll drop it into this folder. And now what I can do is I can choose any number of sprite sheets, press this same little preset button up here, and click Dino, and rapidly import all these characters in the exact same settings as I already have. There's all of them. And now we have everyone imported correctly. What we're going to do now is, if we apply this to the character, obviously, what's going to happen is everybody will now look like this. So if I give this character sprite to character, actually, let's do a quick little thing. What color should Doug's friend be? Red, yellow, or green? Wow, that was some green supremacy. Okay, so we're going to import Doug's friend Vita. Vita is a funky little guy. Obviously, the first step is to make sure we're dragging over this art asset right here. You'll notice, obviously, that changed Doug as well. We lost Doug, unfortunately, but we can go grab Doug back very easily. And of course, that doesn't get applied to the character that was already the base prefab. So we have Doug's friend, and that's beautiful. But you're going to notice that the second I play the game, we're going to lose Doug's friend. He's going to look like Doug again. That's because we haven't updated the animations yet. It's still going to immediately default to Doug's idle animation, and we're going to lose Vita back to Doug. I mean, we love Doug, but we need some variation here. So we're going to actually go over another shortcut for quickly implementing art with animation override controllers. Essentially, if you have worked with the Unity animator before, you know there's a lot of logic and stuff that goes into making animation state machines and animator controllers. This is a very simple idle and walks states, but you can see how it would grow immensely as we add 3 or 4 more states and arrows between them all. No one likes managing animation logic. So why do we have to do that every time we want to make a new character? The answer is we don't. We're actually going to make a new character with animations following this exact same logic as Doug without writing any of the code or changing any of the state machine stuff. And usually you could do that by doing copy and paste, but as we already know from prefabs, if I wanted to copy and paste everything and then change all the animations, if I need to add a state, I have to do that everywhere again. And that becomes a real pain. So what we're going to do is use an animator override controller for Vita. Animator override controllers can be added just as you would add an animate controller. You right-click, go to the Create menu, scroll down to Animator Controller, and 2 down is the Animator Override Controller. And the power of this is actually all you need to do is select the controller you are overriding, and every animation in the original controller is there. This allows you to skip a lot of steps of replicating animation logic. We're going to copy and paste the idle and walk animations, because I don't even want to bother that much with that. And all I'm going to do is drag these new copy and paste animations into here. There's still Doug's animations, which means I have to replace the sprites, but that's the only work I have to do now in replacing the animator controller for this character. It's a lot faster, and it's something that's very, very nice when I don't want to do art implementation for the 3rd time this week. So we grab Vita. I'm going to go ahead and say, let's make sure Vita's controller is on, because that's how you animate these. And we're going to go ahead and just quickly drag and drop these sprites into the animator as if we were animating regularly. Did I get all 4? I only got 1. There we go. Idle Vita. And we're going to add a walk for Vita by grabbing the next 6 that correspond to it. There we go. So now Vita is real. We can prove this by going back to our scene, making sure that character has Vita as its animator controller as it does, and making sure Doug is still assigned as the player controller. And now if we play, the idle animation should be Vita, and the walk animation that I have, and the idle animation that I have, should be Doug. Okay. Any questions on animator override controllers? Yeah. Our next step is going to be talking about scriptable objects. In the case of scriptable objects, who here is familiar with scriptable objects? Who here is familiar with what model behaviors are? And who here just opens Unity and uses whatever script it gives you. That's fine. Honestly, it is very normal to start off developing Unity, and almost everything you make is a model behavior. But it's very important that you realize that that's not the only path you have, especially as you reach more intermediate and advanced design methodologies and understanding of Unity. So everything we've worked with so far is a model behavior. It's a component that gets attached to a object in the scene to add behaviors. The player controller is a model behavior. That's the only script that we have. The player controller is a model behavior. And that's great, and that works fine, but we also need to understand that sometimes model behaviors aren't the best solution. For example, if I want to add character data, if I want Vita to have a different move speed than Doug and be able to switch between the two because they're both characters, what we could do is, we could have different prefabs that have different move speed values. That would work. But then if I wanted to add another character, that means another prefab, even though I'm only changing some values. What's great about scriptable object committed model behaviors is it allows us to script data that can then be used and adapted for different purposes without needing another place to live. And we're going to exemplify that now. So this will be the first script that we write. I'm going to go ahead and right click and add a C# script, character data. Now at this point, when I open this up, most of you are already familiar with the model behavior template that it gives you. This is a great template, works great for when you're making components, but we're not going to use that. We're instead going to make a scriptable object. And we can lose all of this because start and update doesn't exist in scriptable objects. I have GitHub Copilot on, it's going to recommend me a bunch of stuff. We're not going to worry about that because sometimes it's wrong. But right now, what are the things that define a character as a character? Well, it has a name, has sprite for when it's in the prefab view, and it has animator controller. And if we also want to make them compatible characters that can be swapped out with one another, we also have move speed. So what I'm going to do is add all of those as fields on this scriptable object. Public move speed, public runtime animator controller, which refers to our animator controller, public image or public sprite image, and of course, public string character name. That allows us to have a bunch of different fields that we have here. That essentially defines a character in our game. I'm just going to quickly reorganize some of this. Now, the beauty of this is I've got all the fields here, none of the logic yet. How can I add this to a character? If I go back into the scene, I still don't have a way to add it. I'd have to, usually what I would do is I'd attach the model behavior to a character in the scene and be able to adjust all those fields in the inspector on the right, just like I'm doing for player controller. But if I try to access character data, it's not there. That's because that's not the behavior you use when you are trying to work with scriptable behaviors. Instead, scriptable behaviors are a data object that you can use in your project window outside of the game object in the scene. And to do this, all we actually do is add an attribute called create asset menu. I'm going to take GitHub's suggestion there. And all this is going to do now is once we have that attribute there, we go back into Unity. We go back into Unity. We go back into Unity.
No Unity for you.
We go back into Unity, and we're going to make some data. I'm going to make a folder for data because it's always good to keep things organized, even if you're doing a short presentation. We're going to create scriptable objects, character data. Let's make this Doug. And then all the fields we have are right there. The beauty of this is this exists outside the scene. I don't need prefabs to store this data. I don't need to be careful about which data goes where. It all exists in this project folder. It's a file. And that's really great because then we can associate with other things in the scene and not worry about needing more prefabs for those. So I'm just going to associate all this data real quick. And we're going to, actually, I'm going to make Doug a little faster. And what we're going to do is make one for Vita. And this you can copy and paste. This one, we're not doing nested prefabs here. This one is entirely just different data. So there's really no reason to keep it. Vita, yeah. And let's make Vita real fast. So now we have some data. We have data right here, and that allows us to do what now? Well, the one thing we're going to want to set up now that we have essentially a way of accessing data is a way to integrate the data to our characters. we have a scriptable object, but how do we use the scriptable object? It's very simple, actually. It really is just a data container. And what that means is we can just use it in the sense that we would any other piece of data in Unity. I'm going to add a field for character data. I call it data. I'm actually going to make, so actually for reference, I'm using serialized field tags just to keep things private. You don't have to, you can also use public, but this means that I can see them in the inspector without actually needing to open it up to anything else being able to use it. In this case, I'm going to hide move speed now because let's actually keep seeing it because it will help us with the feedback. But I'm going to say, hey, I can assign a data as an attribute. And what I'm going to do is have a set data function set data. And all it does is says, whenever I get new data, there's some things I need to do. I store the data, yes, but I also need to update my animator runtime controller. And I also need to update my image, or I should grab that. All I'm going to do right now is make sure that we have the sprite renderer that actually renders the sprite so we can update its preview image. This will help us. So all I'm going to do now is sprite renderer, get component and children because of how it's organized. Okay. And now I'm going to assign these three things: the data, the animator, and the image, which I just need sprite renderer, image, or sprite, and assign data's image. Now what's going to happen is, I need to call this someone actually, my bad. Almost did something bad. What I'm going to do actually is at the start of the scene, set its data. Makes like a good way to do that. Set data, no, start. And now, don't do that, go away. IntelliJ is great, IntelliJ is great, but sometimes there are some keyboard shortcuts which you do not mean to press. Set data, like that. Like I didn't press that, I swear.
Did you mean writer?
Is this writer? I just did IntelliJ this morning. This is writer, you're absolutely right. I have no idea what I'm thinking of.
You're a fraud.
Yeah, I am a fraud. This is all fake. It's all coming down. But now I have my character, and let's say if I wanted to play as Vita, all I really need to do now, go down to our player controller, drag the Vita data object, throw into here, and at the start of the scene, what's going to happen? That would feel like less of a rhetorical question if it actually loaded. There's our Vita. Vita is slow, which means we didn't update move speed because we're very sad. This move speed equals data move speed. Okay, there's our Vita. Vita will be fast now. What this means is we've actually modularized data from the actual functionality of a character. This is really helpful when you have a lot of one, but only one of the other. You wouldn't want to have 30 prefabs for one for each character if all it is different stat changes and graphics, because it's just a pain to manage. You can see Vita's real fast now. Any questions about scriptable objects? Okay. We're going to do a quick pit stop to talk about modularizing code, and then we're going to end up with custom editors. So modularizing code and organizing code is really personal preference with a lot of options. So I will just show you a few options you can use for organizing your own code. What you actually use entirely comes down to what you think is worthwhile to you. One thing I always use is namespaces. This allows me to kind of group up code into big packets that I can then import if I need to, but you don't have to use namespaces you don't like. Namespaces can be added to any file whatsoever by just including a namespace. If you use Java, it's very similar to the packages in Java. Project character. And all you need to do really is make sure that that code exists in that namespace. That's namespaces. Next up is XML comments. This is the thing that I actually think that everyone should use, if nothing else, because it does allow you to, does force you to make comments. By putting 3 triple slashes in any of the wider IDEs, or I think it's also supported by an extension in Visual Studio Code and Visual Studio, it'll generate an XML comment that works with IntelliSense. So in this case, character data, I'm going to say it's a container, a data character. Yeah, I'll take the first one. I don't actually write comments. That's also the secret. I use GitHub Copilot to write all my comments. I don't write any code. That's the secret. And now you'll notice 2 things. One, since I added character data to a namespace, it's no longer available. That's just because I need to now use that namespace, which allows me to think about, hey, what things should be accessed, what things. Project.character. And two, you'll notice that when I hover over character data, I can see my comment. XML comments have built-in support for IntelliSense, so they will work with functions, classes, and a whole bunch of, and even variables.
Sorry, that's.
Yep, XML comments are built-in support for IntelliSense, so they can work for providing built-in comments and access to your comments for functions, variables, and classes. It's very useful when you're working with big code and just let you quickly see this is the thing I'm talking about. Okay. Last thing I'm going to talk about for organization is regions. Regions are a macro supported by most IDEs that allow you to group up code literally into regions. It's that simple. You say region, I'm going to call this character data. I add an end region tag. And my beautiful mind gets to say, okay, I don't want to look at this, and it goes away. It's gone. That's how you should organize most of your code, by the way. If you can just make it all go away, then there's no code, and it's beautiful. Any questions on those three ways of organizing code? XML comments, regions, namespaces. Daniel.
Sorry, how'd you hide the region again?
Yep. So most IDEs actually pick up on this little macro here, region, and they'll give you a little drop-down arrow right next to it. This allows you to keep lots of big code kept into small packages. All right.
Can you re-explain like what namespaces are?
Sure. Namespaces are best compared to Java packages if you've worked with those, where it's essentially saying, hey, this is a name I'm going to assign to a group of classes and functions and scripts. This is where we define it right here, project namespace player. That's the namespace that the player controller script sits inside of. Using it means that I know that that package includes that script. You'll notice that there's a bunch of using statements at the top of this file. Those are all packages that someone else made. Those are all namespace packages that are made by the system or by me if you look at player with project character. The reason I like to use this stuff, it keeps my mind fresh with, okay, certain classes go in a certain place, which means I know where to look for it. It also means that when you have a lot of scripts, things can go away and literally not be brought up in IntelliSense if you don't import them. What that means is you are not dealing with, I type in player, 3,000 things come up for player. Oh, there's only the namespace. And then when you import that, you have more options. Yeah, any other questions? I have 2 minutes. We're going to see if this works, but we're going to stretch it. Custom editor stuff. Custom editors are a very powerful tool to make sure that you're using Unity to its fullest potential. As you can see, there's a whole bunch of editor stuff. Like everyone uses the inspector a lot, but you don't understand how easy it is to extend it. For example, right now, how we're setting up character data is at the start of runtime, we switch which character data is. That's great, but it doesn't give me immediate feedback of, well, what character is it? There's 2 ways you can actually have the characters change without outside of runtime. Now, the first one I'm going to go over is onValidate. OnValidate is a built-in function that's sort of in the vein of custom editors, but it's mostly just allows you to quickly make changes based off of people changing the inspector. So onValidate, this is not the right one. OnValidate, there it is. OnValidate will run every time a user changes a value in the inspector. In this case, if data is ever changed, I want to call set data. And what I'm actually going to do also is awake just for this demo because it won't work otherwise. Oh, no, we're not using, okay. So what I'm doing here is I'm saying, hey, if someone changed player controller's data in the inspector, onValidate is called. If that data that they changed is not null, i.e. there is data, let's set that data and let's make sure that we update everything accordingly. The reason why I call awake is because I need to get references to the things I want to set, the animator, the sprite renderer, stuff like that. In this context, if I go to player, I change Vita to Doug, they're going to change in real time in the editor. And that's great. In this context, onValidate works fantastic. It's a small change that you can make freely with onValidate. But in some contexts, onValidate can be very expensive. Because realize onValidate is called not every time you change the data you want to change, every time you change any data script. So if I had 3,000 fields in the script and onValidate for each of them, oh boy, every time I change one of those fields, it's going to go through the logic for each. So we're actually going to hide onValidate and make a very quick custom editor. So many shortcuts, and I don't want them right now. There we go. Okay. So inside of our code, what we need to do is make a custom inspector. And to do this, we actually need to make a new folder called editor. The reason for this is editor folders in Unity do not get compiled with your game, which is important because you don't want your game to know about the Unity editor. Why would you? You're not running the Unity editor in your game unless you're doing some very weird meta gaming. So we make the editor folder to put scripts that belong specifically to when we were making the game. In this case, we're going to make a custom editor for the player controller. Called player controller editor. And I actually right now this will be the third thing. The next thing that we actually learn won't just be a model behavior. This will be a custom editor. So we're actually just going to inherit from editor. Come on, you can open. I believe in you. You did it. We're going to, rather than use model behavior, we're going to use a editor. And what we're going to do is add another attribute. That's like we did last time. And this time the attribute will be custom editor. And for what class will it be for? Well, it's going to be for player controller. And now, whenever you make a custom editor, there's essentially one thing you really need. On inspector GUI. This is the function that runs when Unity editor is trying to figure out, hey, what do you want me to draw for this component? Now that we're overriding it, we do want to do a couple things. I call based on inspector GUI because I want all the common behavior of this inspector. I still want to be able to change the data field. What I am also going to do is I'm going to grab the player controller as a value, and I'm going to add a button. Adding buttons is so easy. It is one line of code. It's if editor GUI layout button. Is it editor? No, it's not editor GUI layout. It's GUI layout, isn't it? You can see right now this is the first time I'm actually writing code without GitHub Copilot. This example. Let's call it update data, not set data. Now the format here is a little weird. I'm saying if a button. What it's actually saying is the button will be drawn every frame, but if it's ever clicked, it'll return true. And then we run the functions inside this. In this case, we just want to write characters that set data. Data. Oh, it's hidden. Yucky. It's hidden. For this example, I'm just going to unhide that right now, just so we can quickly wrap up. Cool. Yes, I hit all invalidate already. All right. So now what's going to happen is I have created a custom inspector with a button that just calls set data with the character's current data. I'm also going to do one other thing, which is player controller. The same thing I did in onValidate, which is player controller .awake. The reason being, I have to show that as well. The reason being we need those references to animator controller and sprite renderer to actually make these changes. And this doesn't run until the game starts usually. Okay, so we create a custom inspector. And now when we go into back into the editor, we're actually going to notice the button we just made. Player. I feel like it's just compiled. We scroll down to player controller, there's our button. It's a beautiful button. But what that means is whenever we want to switch, it no longer does it automatically, which is a bit of a letdown. But we can quickly update. The benefit to this, which I didn't show, is that onValidate works in mysterious ways in that it only works when you are working in the inspector. This update button allows me now to essentially work more similar to how updating would function in real time, which is, hey, the game starts, I'm walking around here. If I actually did change characters, it would require player input. And this is a little more similar. Oops, clicked the wrong thing. This is now my player. Whenever I want to switch, I'm able to. All right. Any questions about custom inspector and custom editors? All right. I'm going to wrap up with just a quick little reminder or showcase that all this code is available on the same starter project that we worked with. If you just switch over to the final branch, you'll be able to have access to the completed code if you wanted to look through anything. There should be XML comments and more thorough organization of everything on the final branch. I'll post the live branch in case you want to look at specifically something we did during this demo. But the final branch is probably the one you want to look at. Any questions about anything we cover, or is that all? I think I'm pretty much done. Thank you.